Those sides, what else do we know about circles? I mean, you've done, if you don't know this, like geometry is a part of every math course you've ever taken. There's a little bit of geometry. So that's why you know some stuff, even though you're just now in geometry. That's why you, even though you may not recall it all, that's why you know what circles and triangles and squares and rectangles are, and why you should know the area formula for rectangles is length times width, and this stuff is also stuff you should know that we're going over right now. So there's no sides of a circle. What else? Some specific words that are about circles, parts of a circle.
Circles set all points. Same.
Same what? There's more to that. So what can we? You're just reading. You're right, but what does that mean? I mean, everything you said is right, but I want to make sure you understand what you're reading. So from a center point, if we create points, I'll show you. Oh, that's right. I'm forgetting. Well, let's talk about some vocabulary first before we do this. Give me some words that you associate with a circle. I'm seeing a lot, way too much phone stuff. So you guys need to back off the phones while I'm talking for a little while before I become angry and you wind up on it. That's how it happens. What else do you know? And it'd be different if I was getting all the answers and I'm not getting any answers. What? Oh, did you torn out? Yeah. So you tore out 189 to 226, or you're looking for 189? Okay, over there. Where'd you get that? Oh, they did not have the page. 189. They put it back in the notes. So need to make sure earlier. Pages. So they were turned out, and somebody must put it in a file. So go over to that file over there. Then there are probably other ones that people put back in the wrong pile, just like people always do. What words do we associate with circles? There's 3 of them I can think of for sure. Radius, yeah, you got it right there on the page. So radius, what's a radius? No, wouldn't have any. You use it to find the area, but it has absolutely nothing to do with. No.
Oh, I'm trying to cheat.
I don't care if you read. I never said you couldn't look at the notes.
The lines technically from the center.
So for a circle, from that center point we talked about that we use to basically draw the circle, if we go from that center point to any point that's on the circle, that's a radius. And that's actually what we use to draw the circle, is we kind of use the radius, and we just make sure we keep making points that are that same distance from the center point, which is what that tool is used for, which we'll get to in a minute. What else besides radius do we associate with circles? So diameter, what's the relationship between diameter and radius? So it is. So what does that mean? Well, the diameter would be from one side of the circle all the way to the other side of the circle, but through that center point. It's 2 radius. Basically, one radius. I'm going to do this in a second, a picture. It's basically one radius going one direction from it, and one radius going the opposite direction to the other side of the circle. And then, does anybody have another word on that page? Chord is not one you've learned yet, so we'll skip over chord, but can't remember if this other word I'm thinking of is even on that page.
I don't think so.
All right, so we'll come back to that. So let's go ahead. I want to show you something about aliens first, though. Yeah, show you about aliens. Anybody like aliens? Who believes aliens exist? So there, proof that aliens exist right there. That is a gigantic field. These are huge circles, by the way. Like circles that are like hundreds and hundreds of feet across. Some of them are smaller, like you can see they get smaller, but you can see they're like absolutely perfectly drawn. No way man could do those. Had to be aliens, right? Clearly it's aliens. I mean, there's a whole season about it, like season 19 about ancient aliens and circles, right? Must be alien. No way any other way could that could be done that perfectly, right? Yeah, these people are idiots. They are just advertising how dumb they are in the show. So I'm going to show you why they're idiots right now.
Okay.
I shouldn't be mean. That's. So here's what's that called? Way back in your
Oh.
days. Not a protractor. That's protractor. So that's first guess. Remember.
It's
You know, in your language, is that what you just said? What is it in your language? So who knows that language and then convert it?
it's like someone.
One of my good friends speaks Portuguese, although I haven't talked to her in forever. But you can speak a little, like you can communicate sometimes with people in Spanish a little bit, right? Because she used to be able to talk to some of the people that spoke Spanish. But yeah, it is definitely different. Like there were some things that she wouldn't be able to translate. Starts with a C. Okay. Everybody got it after that. One class got it without that. Last class got it with the fact that it starts with a C.
Yes.
Compass. Yes, perfect. All right, so if this is a so if this is a compass, and we put this part of the compass there, that's going to become the center of our circle. And then we just take it and we draw, because the distance never changes. That's what that tool is for. It sets the distance from here to here at a fixed distance, and then you just spin it around and you create a perfect circle, right? And then you can say that distance that we just used from here to here, oh, that's cool how it changes. That's the radius. And every distance from that center point out to the circle is a radius. Every one of those lines I draw, and I'll draw another. I'll draw a green one. Every one of these lines, assuming it's drawn perfectly straight, which those are not bad actually for me. Those are all the same length because we just created a circle by making sure the distance from this point stayed the same. Create a circle. Now I know why they're dumb. All they did is the same exact thing, only they did it with a pole that they jam into the ground. They tie a rope to it. They attach the other end of the rope to their tractor, and they drive around, making sure that they keep that rope tight. That's how they created every one of those circles. And if you'll notice, there's a center point here. So that's how they made sure all of the middles of those, they drew some kind of a line first. So every one of these circles, you can almost even see, you can see where they kind of drew, like where they went between circles right there. Then they just put a point all the way around on those and they created more. Now, somebody has a lot of free time on their hands. I'm not gonna lie about that. But you can even see here, this is a point. They went from these circles, they drew a circle here first, and then they created those little, I mean, you can see where they kind of went through as they went from one like middle of a circle to the next middle of a circle. That's all they did. So I'm not sure if anybody believes that was done by aliens, but I'm pretty sure that one, not proof of aliens. Somebody just had a lot of time on their hands and wanted to go ahead and do this and make people talk about it, which they did. What's that? Oh, it's cool, don't get me wrong, but it's not aliens. So, and again, here they just did a circle and then they moved in and did a small circle instead of mowing all the speed or whatever. Well, apparently, like if you listen to this, I listened to a little bit of it. They apparently do it the same time of year every year to make it seem like it only pops up at certain times of the year or something like that. So that's where all of it, again, all of the mystery comes from, is that they're very smart about the way they do it, and they kind of do it at a certain time of the year. They do it, I'm sure, when they do it when it's time to, like, harvest beans, like when it's time to like harvest the wheat. I'm sure that's when they do it because they need to harvest the wheat anyway. They just start by doing this little thing first. It's actually not, it's not in the United States, that particular thing, but I've seen it in other places, but that's in England or something. So yeah, so all they did, they took something, they put it in the middle, they kept the distance from that the same, and they created a circle just like we use that compass tool to create a circle, same exact concept. So within this circle, we'll just talk about those other pieces. If I drew this, oh, actually, I have one here, never mind. So if I took this line and I put it from one edge of the circle, there, pretty good. From one edge of the circle to the other edge, that's the definition of diameter. Actually here, let's go back a little bit. That's probably close enough. Yeah, there, that's close enough. So that black line is the diameter. Again, the diameter is made up of one radius here and one radius here. So if you know the radius and you multiply it by 2, that's the diameter. If you know the diameter and you divide it by 2, that's the radius. That stuff you should already know. Actually, the next thing we do, you should already know also. If you don't remember all that stuff, then you're gonna need to make sure that you practice that, because otherwise you're gonna struggle when we get to the tough stuff on this lesson. Here's my, oh, here's the book. Uh-oh. Oh man. Timed out. Let's see if I can restart it without. Looks like it. I actually had already recorded this lesson in 4th period, but I got really off on a tangent and I had to write a referral, so I decided to re-record. Yeah, so I'm just reporting this class. Yeah, the other class, there was a whole bunch of extra stuff that made it longer than it really needed to be. All right, so there we go. Oh, no, there we go. First, so we're on this first page here. I'm going to go over it pretty fast now. I kind of gave you the majority of the lesson, really. So we talked about center of the circle, radius. All these are our line segments, by the way. So a lot of the stuff we did in line segments, like a little line or a big line segment, but then we split it into 2 smaller line segments. Those 2 smaller segments have to add up to the big line segment. So that concept is still in there. One new definition that you haven't ever learned, most likely. If we have 2 points on the circle, and if we connect them with a line segment, that is called a chord. So just underline that, understand, anytime you have 2 points that are on the circle and you connect them with a line segment, that's what you call a chord. So that means the diameter is actually a chord as well. It just happens to have a very specific name, which is the diameter, but it's a chord. This CF, this radius, is not a chord because it doesn't connect 2 points that are on the circle. It connects 1 point on the circle and then the center. I guess that's all right for this stuff. Hopefully you know this stuff. Oh, they use this weird word, radii. It's the plural of radius. So whenever you have more than one radius, that's the plural. I'll sometimes say the radiuses, just so you're clear on what I'm talking about, because radii, some people are like, what is that? I've never heard that before. Well, it's just a plural version of radius. Here are the formulas you need to know. We've already talked about the fact that the radius is the diameter divided by 2, or you could say 1/2 times the diameter. The diameter is 2 times the radius, so we talked about that. This one you need to know You really just need to know one of these formulas, and you should be able to figure them all out. Good. I didn't know if you needed me. So all four of those can be derived from just knowing one of them, if you know how to solve for formulas. But you need to know, you may still want to circle them and make sure you know them. The main one, if you just want to learn one, that's the one I would learn. From that, you should be able to, oh, I forgot to tell you. So you know that number pi that you think of probably as 3.14, it's not actually 3.14. It goes on forever. It never ends. The reason we call it pi, or well, actually, I don't know why we call it pi. The reason we use a symbol though is because it never ends. You can't write it down. Like it's a number that has no ending, so there's no way to write that exact number down. Whenever we write 3.14, we're rounding it off. It's a measurement of the circumference of a circle, which is what? What's the circumference of a circle? That's the other word I said you should know that wasn't on the first page. What's the circumference of a circle? Not the circle. I'm sorry, not the area. That's the space inside.
Oh.
So it's the length. I should have done this with the perfect circle I had. So that is not a good circle. I can't. Unfortunately, I can't really use the tools in this. So I'm going to tell you it's like the distance around the circle. So if I was here, I was a little itty bitty tiny ant right there. And if I walked around the circle and got back to the starting point, the distance that I walked is the circumference. I'm sorry. Yeah, the circumference. Or if this was a string perfectly laid out in a circle and I cut the string right there and I took that and stretched it into a straight line, I measured it, how long that string, that line is also the circumference. If you have something round like this, and if you wrap a string around it, we actually did this activity when I taught 7th grade. We wrapped a string around something circular, and we measured how long the string was where it reconnected. That was the circumference. You then take the diameter, which would be from one point on the circle to the other side through the middle. So we measured that and we divided it out, and we should have gotten what pi is, 3.1415, blah, blah, blah. So I think whoever came closest to that number won something, some kind of prize. But so if you take that circumference, you divide it by diameter, that's what this person here figured out. Every time he did that, no matter what size the circle was, he kept getting the same number. Little tiny circle, if he took this divided by that, he got the same number as if he took a gigantic circle and divided the circumference by the diameter. So that he created pi, basically. Or not really created, but I guess figured out that that number exists. I would say just memorize this one here. And from that, you can, assuming you know how to do a little algebra, you can solve for anything you need. Circumference, radius, whatever you need. Okay. So here's what I want you to do. On the next page. What in the world? Oh, there. Well, oh, there. So on the next page. Oh, it's not letting me do it. I want you to do actually the next 2 pages. I want you to do all of the examples and all of the check problems. I think there's actually only 1 check. Maybe 2. There, I want you to do all the problems on those 2 pages. They're not difficult. Some of them are just solving for the radius or the diameter. Some of them are solving for circumference. I will help you out on example 3 if you want to look at example 3 real quick. So they're asking you to find the circumference of the circle. All they're saying is that these cars, doesn't matter which car you pick, even if you consider that car there, all of these cars are 18 meters from the center of that little roundabout. So this car would also be 18 away. Because it's a circle and they're all on the circle, and the center, that circle would be the center of the roundabout, which means these are radiuses. They're all the same number. So there's something to help you out. Doesn't matter one class or the very first class, somebody was confused about which car do I use. Doesn't matter. They're all on the circle, so that every car represents a radius.
Sorry.
Yep. I'm gonna say I probably can get it figured out a better way. I mean, not a better way, but more out of the time I find that. Try that, it works.
Yeah. I was trying to flatten it out because they bent it the other way.
Oh, so were you trying to just take the staple out now?
Yeah, so I can, I think, staple it like on an angle, so it'll fold over.
Okay. Did it come out point?
Oh.
Yeah, I don't know why it did. I mean, I know there's a way to change the stapler so it does that on purpose, but normally you have to like take the whole metal insert out and flip it over. I want you doing some of this stuff, so hurry. Get fast. Oh, you have your phone? I said you can go, but come back fast so you can do this stuff. Oh, all right. When if you don't understand these, again, everything you're doing on these 2 pages is easier than what's on the quiz. Like none of this will be on the quiz. So if you don't even understand this, you're gonna struggle on the quiz when I get to the stuff it's actually kind of hard. Well, even the first thing we do still isn't hard, but harder than this stuff. You need to use it. I'll give you like 5 minutes. You should really be done with these after about 5 minutes. Come on, girl. You need to practice these easy examples so that you're ready and get the cover. Do you have your own? Calculator. Oh, all right. Yeah, I'm down still to 16 calculators, so I'm saying it, but no more here. If you have a calculator, please bring it back in. Back in when we fix our goals. I had 20 something at the beginning of the year. Let me do it 10. Did I do a 10?
I think so.
All right, let me do attendance real quick, and by the time I get done with that, probably be about time to. Actually, tell you what, I'll do attendance after. Oh, better. Go Hannah today, huh?
Yeah.
That means you're gonna get a lot of work.
I already have this done.
That's what I'm saying. That's my point. Yep, that's great.
It seems like any way I did this, like if I multiply these two together, but I can actually calculate it. It's the same.
Yeah, it's. Oh, if you didn't know it, speaking of that, if you didn't know it, there's a button for pi on the calculator. You should already know that, but like, instead of typing in 3.14, which is actually rounding it anyway, if you just say times and then you hit the pi button, which is where?
Oh,
It's to the left of the sign. Yeah, if you see where cosine, sine, all that, it's to the left of that. If you just hit that button, just like it's a number, because it is a number, that'll just automatically put all of pi in for you, and you don't have to type in 3.14.
Really, that's another side. No, there's the first setting.
I put in, actually, I should know. I can't even think of the way I've already used. Definitely heard it.
This is the sentence, the causal mother things. When you're talking, father kind of.
Oh, there's, I mean, must mean like
Oh.
calmness or balance. Or something like that. What's the actual definition?
These are the easy.
Yeah, they should all be easy. That's why I'm not really doing much of a lesson on them. None of this stuff on these 2 pages should be difficult. If you're struggling, you need to make sure I'm not really even doing individual stuff on it. When I go through it before the class, you better ask a question if you're struggling. Don't be embarrassed unless you're gonna learn it on your own, because it's gonna get harder when we get to the next page. Not a lot harder yet, but
But the
it will
width,
definitely get harder on Thursdays.
the width of the circle just.
Why, I'm asking, is that what you're talking about?
And would it just be?
If you are going from one side of the circle to the other side to the middle, that's diagonal. Now, if it's not through the middle, then it's not. That's a big, big. I gave you the drawing. Far to the center.
That's okay.
I mean, again, all example 3 is a circle. Get confused because it's a word problem. It's a circle and the radius is 18. And you're solving for circumference, which you have the formula for circumference on either the same page or the page before. Give you a couple more minutes and then we'll start going through them. Oh, I something new with it. Oh, that's. Not sure that's. I can just put
It is the water there.
I thought best thing, better than nothing. It's- Your next deadline for a quiz is next Monday. Deadline just passed yesterday for one of them.
I am. Yeah, because, that's been. Which is the radius. Also there. And then X threes, CT is a chord because it's, it like connects through the radius. There's one long line, and then I'm pretty sure this is the diameter, because it's the center dot.
You got 30 more seconds, and we'll start going through these. What's that?
So. Interesting to try to measure these.
Yeah, that was a real.
But I'm like question.
Well, that's what I'm saying. And I'm gonna do the drawing, like, if this question is totally up to your interpretation of the drawing. Like, in the first class, I interpreted it differently than somebody else. Now, based on the way we thought you were saying, we were both right. It's just she had a different understanding of the way hubcap works than I did. I'm gonna draw that out. But,
Yeah, I'm confused with why is it saying 15? Yeah.
well, what answer would you get for the circumference of that? If that was, well, actually, that can't be correct, because what's true about what is 7.5? It's the radius, right? But shouldn't that match
Yeah.
this radius? Yeah, so that's not the end drawing. But definitely that drawing
Wait,
definitely.
so then.
Do you know what a hubcap is?
Girl, this one is the diameter is divided by 2. And I get it. This diameter is 11. So then this, wait, I'm confused. Yeah, 11 divided by this even, because it's the same thing, just count sideways.
Yeah, this is not.
And then it's work. And I guess it's also it's split into caps. Like that.
Yeah, but that thing.
I don't know if that's the reason why, but. Oh,
So what I assumed is the radius of this was the 7.
because this one is 14 divided by 2.
Yeah.
And it equals 7.
Edge.
So I figured that's also kind of half, 11 versus 2.
So the inner edge would be this 7.5. And then the tire itself was 6. And that's where she thought of it as, well, no, the hubcap covers up like almost the whole tire, so she added them together for her. Oh, I just used 7.5 for my radius. Yeah, oh, the formula doesn't change. It's always circumference equals this times this. We just had a different answer for diameter. My diameter was 7.5 plus 7.5. That was when I was using the inner circle. Hers was, she added both of these together and said the whole thing was diameter. I'm sorry, whole thing was radius. So then she doubled that. So she came out with this answer, I think. This answer. I got this, she got that. And again, based on our interpretation, we were both doing the right thing. Just, I don't know what they mean by hubcap, if it's supposed to cover up the tire or not. All right, so we'll go ahead and go through them. First two for sure should not be difficult. I mean, you're just naming them in this. The main thing you need to, oh, here, actually, I do want to do this. I've done it with every class, so I should go ahead and do it with this class. So you should understand what the radius is. So give me, using the letters, give me a radius from that circle. So X to Z is a radius, right? From the center out to the edge of the circle. Give me another radius. So again, from the center. Yeah, what do I need? Blue. Give me another one. X what? Or V. Okay, I said P. There's another one. And you should be able to give me one more. XT, right? So there, we have a bunch of radiuses. So now let me ask you this. True or false? The length of the diameter is equal to blue plus green. So what is the diameter then? So red and black would be the diameter, right? But what was my question? Not exactly my question. That the length of the diameter is equal to blue plus green, right? Let's say red is 2. What's black? 2, right? So that's the diameter. So the diameter is 4, right? Well, what's red? I'm sorry, what's blue? So what's blue?
Oh, some more. Okay.
No, because red is 2, black is 2. So what's blue? 2. They're all 2. Every radius is always 2. So green is 2. So is blue plus green equal to 4? So it was equal to the length of the diameter. I need to get more focus from you two over there about things. Because that was an important topic. I don't know that I feel like you guys would answer correctly. So again, you need to understand every radius has the same measure. A very common theme or type problem is to somehow give you some information that would allow you to create an equation based on the fact that any radius of the circle is equal to another radius. Ladies, that's gonna need to change too. So I need you turn and facing this way for me. Because again, our quiz grades have gone slowly down in this class. So I'm gonna grade this last one and we may have some changes after you. Well, actually, I did. No, you had one yesterday. So I'm gonna grade that one, which was a pretty difficult one. They're not good. There can be some seating changes. So I already had some seating changes. So I'll do a few more if I need to. But you need to understand that concept. And again, it may be that they give you the diameter, not the radius. And then you somehow have to compare half the diameter with one of the other radiuses of the circle. But that is, I would be shocked if that's not something you're gonna see in my quiz, the EOC, all of that. These are pretty quick. Again, none of this is difficult. None of this will be on the quiz. You need to understand this before you can even get to the more difficult stuff that will be on the quiz. This stuff, not hard at all. Shouldn't be. So if I want to know, what is it saying? TU is the diameter. So that's a diameter. And they want to know the radius. I just divide that by 2. Cut it in half. So that's what they did to get 7. They already did that one for you. There was no, again, they did the whole problem for you on that one. So same exact problem. Actually, it wasn't the same problem. So let's go over this one. So if they tell you in this case, LM is 11, they want the diameter, which would basically be from J to K if you want to use the line segment. So what was your answer?
5.
No. Yeah, they gave you the radius, and so they flipped it a little bit. This one you just divided by 2 because they gave you the diameter, and that one up here they gave you this. That's not what they gave you down here. So down here you had to multiply this by 2 to get the diameter. It was 22 actually. So be careful. Make sure you think about what you're solving for. Down here, once you understand, I can't zoom in. Oh, actually I can zoom in. So once you understand, this is the part I told you, clarified for you, the circle is say it's this thing here. Oh, I messed it up. I was doing so well. So that's the circle. These cars we're saying are on the circle. So that means this is called what? Yeah, it's radius. So if that's the radius, and I know it's 18 because they told me it's 18. I just plug that into the formula for circumference. And you can use, again, any of them will get you to the answer. So there's this one. I always just remember this one. That's the only one I really ever worked from. I just then, boy, I just said something about phones too. So I just take this, if they give me a diameter, then I divide it by 2 to get that. And then I wind up multiplying it by 2 again, because that's the formula I like to use. So in this case, they didn't give me diameter, they gave me radius. So I'm just going to plug it in. So that's what you would solve. I think the answer, if you multiplied it all out, was 113, I believe. Is that what you got? So that, again, won't be any questions that easy, but you need to know that stuff before you can do the next step that we're about to do. So I'll go over this one. It's not difficult math, but the drawing part is difficult. So, and it kind of depends on your interpretation of a hubcap. So if I have a tire, to me, the hubcap is this thing in here. Like, how do they say it? Yeah, the inner edges of the tires would be this. And they say the distance from the inner edge is 7.5. So to me, the hubcap just covers that. I don't need the 6. Like a 6 does nothing for me because this is the hubcap. This is the rim. I'm sorry, hubcap is a rim. If you don't know that. So I would just say that's the rim. That's the circumference of the rim. But a girl in the first class said, well, I added them together because she was under the impression that it covered pretty much the whole wheel, which I have seen them where you can barely see any tire. So it just depends on your interpretation. For me, if I'm figuring out circumference, I would have used 7.5 and gotten this answer. Oh, you notice they leave pi in the answer, by the way. So if you had multiplied times 3.14, blah, 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 and you come up here and you don't get the answer, either you have to go back and do it and don't multiply times pi, or you could just convert these all into decimals and multiply or 15 times pi, 27 times pi, 13.5 times pi. So that's another option to convert all those to decimals and compare them with what you got. If you interpreted it more like she interpreted it, then you would have said that the whole radius is the 7.5 plus 6. So you would have said times, what's that, 13.5, and she got, which is also up there. So that's why we didn't know how they like are using a hubcap. I mean, you can't really give I guess that's maybe why this is here. Although I don't think any of those really applies to what we were just talking about, but we did assume there was no space. If you did it her way, you assume this. Because she just added the 7.5 plus the 6, which means there's no space in between the hubcap and the tire. So again, mine will not be as hard to understand as that. It'll be something that you can relate to. Not just yet. Are they out there waiting? Somebody out there waiting? I saw you looking out. They can wait for a second. Let me get through these. Actually, the next part is the new lesson, so you kind of need that too. Let's see. Oh, so again, this is not super difficult. You're just plugging in now. We know the circumference this time. You didn't do all of these. Hopefully you're keeping up. So now I still use the same formula. I'm actually going to use the formula I typically use. I'm going to use that one. But now I know the circumference. So I'm plugging in 77.8 to pi r. I want to solve for r. So when you go, again, I'm not going over the algebra. If you don't understand the algebra, then you need to get with me over the next 30 minutes or whatever you have to practice. And then again on Thursday, I divide by those two things to get rid of them because I want to get r all by itself. Well, that means I divide over here by that. That will give me the radius. So I didn't do this in the calculator. You have an answer here though for diameter, so you can figure it out from that also. If I want the diameter, then I would take whatever I get here, multiply it by 2, and that will take me to the diameter because the diameter is 2 times the radius. So my guess is I probably got down here r equals like 12 point. I probably got something like that. And then if I doubled that, if I multiplied it by 2, you should come up with that number. If you're not getting these numbers, then you can get with me when you start to practice. I'm not going to make you do this, but I'll just explain what they're doing here. So they said estimate the diameter and the radius. Pi is 3.14. But if you want to divide without using a calculator, you could say, well, let me just round pi off to 3. So if I round pi off to 3, and if I know this is the circumference, well, circumference divided by pi would give me diameter. So if I just said 94.2 divided by 3, that's a good estimate of what the diameter would be. Well, if you do that, you get that number right there. And then you take half of that to get the radius. Then when you actually, did anybody do that and come out within the actual number? What'd you get for the actual number? I think it was less than 31.4 or something. I think it was higher than 20. What did you get? Yeah, that was it. Because I can remember we rounded it to 30 because even if you round that to the tenths, it's going to bump the 29 up to 30. So the diameter was 30, which means the radius would be 15. So that's all your answers on those two sections. Now let's get to the one that's actually a little tricky. So if you're waiting on the bathroom, I need you to hang in there because this is actually what might be on the quiz. What I'm about to show you. Oh, can't do that. All right. So here are two things you just need to know. Wow, you've been gone long. Oh, totally forgot you were even out. Interesting. If two circles, because again, there are no sides of circles, right? Circles don't have sides. So what that means is every circle, if you have the same radius, every circle that has the same radius is a congruent circle. We did reflections and rotations and translations a while back. Well, there's no way to reflect a circle. There's no way to rotate it, flip it. That's it. Circle to circle. So therefore, if you the only measurement of a circle is the radius. So if the radius is the same, then they are the same circle. They're congruent circles. Every circle, like even if they're different sizes, every circle is similar. Because again, there's only one measure. If we keep it to be a perfectly round circle and we just shrink it down, it's going to be similar. There's no way to make a circle that's not similar to another circle. If there's only one measure you can do, that's dilate it. You can't flip it. You can't translate. I mean, you could translate it, but that wouldn't really affect any size or anything. So any circle is similar to any other circle. And if they have the same radius, then they're congruent circles. This is a definition you've probably never learned also. If you think about a flat plane, you have a circle within a circle and they sit on the same plane. That's what this is saying. So basically it means the circle that sits on here, the second circle can't be angled in any way. It has to be sitting basically right inside the other circle. So they're on the same plane. That's all that's saying. I don't even know if that's going to come into play in the lesson. I think it will, but just so we go over it. All right, so here's the problem that will be on your quiz, something like this. I want you to try to do it first. So try to do that one first. Plug in, I would draw into the figure, personally I would put in the figure the information they're giving you, and then use that to see if you can solve for what they want. Give you a minute or so. If you're getting it, it won't take you more than a minute. If you're not getting it, then I don't want to sit here and wait too long. You have some examples that are going to be like this anyway that you can practice. Start highlighting some stuff if that can help. Not putting the numbers in, but I'm kind of showing you what pieces you should be able to put numbers into. So those three pieces, you should be able to put numbers with those three line segments, which will then allow you to solve for the line segment there. Another minute or so. All right, so let's start plugging them in. If you didn't finish it, you have 4 practice that are, I believe, just like this. Start by just filling in what they give you. So I like writing it in the figures. So I'm going to write it right in the figure. Says the diameter. Oh, I don't remember if I don't think I did this. So this is just the symbol for circle. So that little guy right there, just like we used to say triangle ABC, that's just the symbol for saying circle. So don't freak out when you see that symbol. They're just saying circle K. And you always name a circle by its midpoint. So if they call it K, circle K, then you know that is the midpoint. From here to any spot on the circle is the radius. That will always be the midpoint if it's the name of the circle. So what do we know then that we can write into that circle? They give us one thing, but that's not really what we should write in the circle. What do we know about circle K? So what do we want to write in? Because again, we don't really care about the diameter. So what do we want to write in? What is it? They tell us the diameter is 12. What else does that tell us? There's another thing you should immediately think. Yeah, the radius is half of that. 6, perfect. So for the green line, I'm gonna write everything in black just because green doesn't show up that well. I'm gonna put the 6 over there just so it's kind of out of the way. So that green line is 6. So again, it's gonna be a little tricky in your pictures because they're pretty small, but you could do this. This is what I did in the other class. So DK is 6. So that'll help you kind of make sense of what you write in the figure. So now it says the diameter of J is 20. So what else can we write into the figure now? Of radius of,
You said which one?
I said circle, the diameter of circle J is 20. So the radius would be what? So what line segment is the radius that is 10? So the radius is 10. Radius of circle J is 10. What line segment would that be if I were to write it like I did the DK 6?
JP.
So it would be from the center of this circle, because this is circle J, from this circle to the edge of this circle. So the red, you said JE, right? So JE is 10. So again, the red line segment up on my drawing is 10. And then it just tells us one more piece. It just says here, JD is 8. So if I put 8 for the blue, and then now it wants me to figure out what? EK. What do I do? I didn't write the other one in, so we'll write the other one in. So this is for the red line up here. So the red line is 10. I'm a little worried about this one also. You guys are fast running out of time. It's quarter. Yes, ma'am.
The diameter 8 is 12. Wait. What did you?
So will they ask, what is EK? But EK is only a part of that one line.
So
Raise your hand if you think you got this. 2 is involved, but 2 is not an answer. So if you had 2, that's not the right answer.
no, I mean
You need the 2, but where does the 2 go?
52.
We'll use the letters.
E and
So DE is 2. So this little tiny segment, I guess I'll just write it in. That little tiny segment is 2. So now we can come back around to what they're asking. We know from D, so basically the green line, from D to K is 6. We know DE, that little short line, is 2. So what is EK? 4. So if you got to that, then you're where you need to be. Again, it will get more difficult. This is the easiest question, the easiest level question that will be on the quiz. None of that other stuff before this will be on there. That stuff's way too easy. That's like middle school, maybe even before middle school geometry or some of that. So here's your problem. Some of these, again, are just to make sure you get them. Although I did like one of them that I thought was easy at first. Page 193, 194, and I'll point out the problems I like. 193 and 194, those are your practice problems. 9 through 26. You can look at 1 through 8, it's just naming, but you're going to get plenty of like practice, I guess, in the naming just when we just do problems in class. So let me show you. Oh, number 23 through 26 are like this. So something like that's definitely going to be on the quiz. So 23 through 26, make sure you can do those because it's like example 5. And I will definitely be putting something like example 5 on there. I really like this one other problem though. I didn't see it. I didn't notice it at first until 5th period. I didn't notice it during 4th period.
Wait, what?
Oh, my.
I think that's on page, it's the 2 pages together are 193 and 194. So you're just doing 9 through 20. Yeah. 9 through
Oh.
26. So it's on those 2 pages. I kind of liked 11. Question 11, you may want to circle. It's an explain, I like explain problems, so.
Yeah.
And there would be several ways to explain it. Yeah, yes. And I'm through all of them. Did somebody ask me also after? Did somebody else ask for retro? Okay, so I told her that she could wait, so after she gets paid. I held her. So I did kind of like 11. So make sure you look at that and see how you would try to explain that. You have quite a bit of time. You should be able to finish the majority of these questions. Oh, let me stop the recording. And then I will do attendance. So please show me you can work where you're sitting.